problems from your notes. It's number 3 on your notes. It's a proof. Please remember about a proof is that with the equal sign, it's not really truly an equal sign. You can't move things from left to right. You have to either stay on the left side or on the right side. And you have to get the left side to look like the right side or the right side to look like the left side. I'll be doing 2 different proofs of this. And so you can kind of take a look at either way, whichever one makes the most sense to you. If you were to look at this, and if I were to ask you which side looks, which side looks like you could do something more with, I imagine, I could be totally wrong, but I imagine that most of us, at least I would too, probably say the right side. Now that doesn't mean it's necessarily the correct side to start with, but let's go ahead and start with the right side. So we have this tangent of 2 theta equals 2 tangent theta. Probably the thing that you want to write is that, well, we'll just write it. Let's start it out this way. 2 tangent theta over 1 minus tangent squared theta. So on the right side, it would follow tangent 2 theta. We probably would turn to sine theta over cosine theta all over 1 minus tangent squared. Now, if it was 1 plus tangent squared, that's secant squared theta, but 1 minus tangent squared, we don't have anything for that. So let's just write that out as 1 minus sine squared theta over cosine squared theta. Okay, mathematically, when I'm trying to combine a number with a fraction by addition or subtraction, we have to get a common denominator. So put that over 1. To get a cosine squared, I might then multiply both top and bottom here by cosine squared theta, which means then it would follow on the right side. The top stays the same still. We have 2 sine theta over cosine theta all over cosine squared theta minus sine squared theta divided by cosine squared theta. This time, I hope those math spidey senses are kind of going off. And you can say, oh my gosh, I have a fraction divided by a fraction. I don't like that. So then it would follow that I have the top, which is 2 sine theta, which this like 2 is over 1. So I'm just going to put the 2 with the sine theta. 1 times cosine theta is cosine theta. So that gives us 2 sine theta over cosine theta. Change the divide to a times. Put the cosine squared theta up top. Now the denominator is kind of interesting. Cosine squared theta minus sine squared theta. You've seen this before just recently. Cosine squared theta minus sine squared theta is cosine of 2 theta. Now, please be careful. Remember that cosine squared and cosine 2, totally 2 separate things. Cosine squared theta is like cosine theta. This is the same thing as cosine theta times cosine theta, which now, through multiplication and division, one of those will simplify with one of those, leaving us with 2 sine theta cosine theta all over cosine 2 theta. Now, hopefully you remember seeing 2 sine theta cosine theta. 2 sine theta cosine theta is sine of 2 theta over cosine of 2 theta. And now if I have sine of 2 theta over cosine 2 theta, that leads me to tangent of 2 theta, which is what I have over here on the left-hand side. Therefore, tangent 2 theta equals 2 tangent theta over 1 minus tangent squared theta, because I got the left side and the right side to be exactly the same, only staying on one side. Okay, now I said I was going to show you 2 different ways to do this problem. So that was way number 1. I'm now going to show you way number 2. Okay, I'm just going to do it on this piece of paper right here. So again, we're going to start out with 2 tangent, sorry, my bad, rewrite that up. We're going to start out with the tangent of 2 theta equals 2 tangent theta over 1 minus tangent squared theta. Okay, well now, instead of starting with the right-hand side, sometimes it might be beneficial to start with the left-hand side. So, let's try it. Tangent of 2 theta, well, it follows from the left-hand side we would get sine of 2 theta over cosine of 2 theta. All right, because tangent is sine over cosine and 2 theta, so sine of 2 theta over cosine 2 theta. From there, it would follow the sine of 2 theta we just learned was 2 sine theta cosine theta divided by cosine of 2 theta we said was cosine squared theta minus sine squared theta. Okay. Now, this is going to kind of seem weird. And sometimes, again, navigating through these is a little bit tricky, unless, of course, you have somebody that knows the terrain or knows a little bit better. But sometimes it might be beneficial to take, and I know that we do really well with kind of simplifying out denominators, but sometimes we can add denominators. In other words, what if I said that I want to divide both the top and the bottom fraction by cosine squared theta? I know that sounds kind of weird, but just stick with me for just a moment and let's see what happens here. Okay, so then we get this divided by cosine squared theta over cosine squared theta minus sine squared theta over cosine squared theta. So then it would follow that we would get 2 sine theta over cosine theta, because this would simplify one of those, divided by cosine squared over cosine squared, which is 1, minus tangent squared theta. And sine theta over cosine theta is tangent of theta, so 2 tangent theta over 1 minus tangent squared theta. And if you remember correctly, right back up here, we wanted to get 2 tangent theta, 1 minus tangent squared theta, 1 minus tangent squared theta. So therefore we could say that the tangent of 2 theta is equal to 2 tangent theta over 1 minus tangent squared theta, because, where's that at? Oh, I came off the paper, sorry. So we could say that tangent 2 theta is equal to 2 tangent theta over 1 minus tangent squared theta, because we got the left-hand side of our proof to be the same as the right-hand side as our proof. So we know that they are equal. All right, hope that helps. Have a great day, guys. You're doing awesome. Keep it up. And we'll talk to you later.